When drivers of future Mercedes models hit the accelerator on their electric performance cars, they'll experience a significant boost in power, thanks to a technology that feels straight out of Asterisk, Back to the Future Asterisk. No, it's not flux capacitors, but axial flux motors. For the past decade or so, the automotive world has been longing for a breakthrough, and Mercedes-Benz has raised the bar with a groundbreaking engine technology unlike anything seen before. So how does this revolutionary engine work, and when will it hit the market? If you're not aware, Mercedes-Benz holds the distinction of being the first true car company. Their first vehicle, the Benz patent motor car, model number 1, was produced nearly 140 years ago in 1886, marking the birth of the automobile. Ever since, Mercedes has been synonymous with luxury and prestige. Let's be honest, everyone desires a Mercedes. Whether you're just starting out or incredibly wealthy, the brand has always been an aspirational choice. But Mercedes' appeal doesn't rest solely on its heritage. Its reputation has always been reinforced by a commitment to innovation and experimentation, a trend that has persisted since its inception. For instance, did you know the first self-driving car wasn't a Tesla? In fact, it was an experimental Mercedes-Benz W114 250R automatic, tested 55 years ago. Fascinating, right? And did you know the first true road-going supercar wasn't a Ferrari or Lamborghini, but the Mercedes-Benz 300 SL? In our opinion, the 300 SL is still the most stunning car ever built. Just look at it. It radiates elegance and sportiness with ease. And those iconic gull-wing doors? Simply impeccable design. Mercedes-Benz, as it always has, is now shaping the future of the automotive industry with this cutting-edge engine technology. After years of hard work, the fruits of their labor are finally here. Now, let's dive into how this new engine works. Mercedes-Benz's recently introduced axial flux motor represents a radical departure in design. Though it's an electric motor, it operates very differently from those in Tesla models and earlier EVs from Mercedes. The most significant distinction lies in the alignment of the rotor and stator. In an axial flux motor, the gap between these two components runs parallel to the axis of rotation, unlike the conventional radial gap motor, where the magnetic flux between the rotor and stator is aligned perpendicularly to the axis. This design allows the motor to be much slimmer, resembling a pancake in shape, which is why it's often referred to as a pancake motor. In contrast, the radial gap motor, with its cylindrical geometry, has been the standard because it was cheaper and faster to mass produce, requiring fewer magnets. However, the axial flux motor generates significantly more torque due to its rotating component being positioned on the outer diameter. The axial motor design delivers up to 40% more torque compared to similarly sized radial motors, while also reducing the overall size of the motor. Torque is a crucial factor for electric vehicles, and having more of it is always beneficial. Additionally, axial motors are much easier to cool, meaning they can handle prolonged use without risk of overheating or strain. One of the leading names in the axial flux motor industry is the British company YASA. Founded in 2009, YASA has been dedicated to bringing axial flux motors to the commercial market. In 2015, they outfitted an electric vehicle with 6 axial motors, which went on to break records at the Pikes Peak climb, effortlessly conquering the challenging terrain. This achievement drew attention from key players in the automotive industry, most notably Ferrari, which partnered with YASA on a top-secret hybrid supercar project. 9 years later, the fruits of that collaboration were revealed in the form of the Ferrari SF90 Stradale, the world's first hybrid supercar. The SF90 featured 3 axial flux motors developed by YASA, combined with a 4.0 twin-turbo V8 engine, producing a total of around 1,000 horsepower. However, the SF90 comes with a steep price tag, starting at over $500,000, which limited the potential for YASA to mass-commercialize the axial flux motor. Fortunately for both YASA and consumers, Mercedes-Benz recognized the company's potential and, in 2021, acquired YASA, providing the funding needed to advance axial flux motor development for their own vehicles. This acquisition allows YASA to fulfill its original vision, with Mercedes-Benz leading the way in bringing this technology to more mainstream vehicles. The question now is, when will axial flux motors enter broader production? In fact, they technically already have. Mercedes recently unveiled the Mercedes-Benz Vision 111, first car to feature an axial flux motor. The Vision 111 pays tribute to the iconic Mercedes-Benz C111, a similarly groundbreaking vehicle. The Vision 111's design is breathtaking. Its LED front end seamlessly integrates with the car's retro-futuristic aesthetic, and as a nod to the C111, the Vision 111 is equipped with gull-wing doors, a feature long awaited in modern Mercedes sports cars. The car's striking orange color is another homage to the C111, and the interior is a design marvel in its own right. The retro interior is so stylish, it feels like it just needs a few Nixie tubes to complete its 80s-inspired vibe, which we absolutely love. The sleek silver bucket seats look as though they've been pulled straight from a rocket ship, enhancing the car's space-age feel. In fact, the entire Vision 111 has the appearance and atmosphere of a spacecraft, making it seem like something straight out of Blade Runner. It's easy to imagine Rick Deckard behind the wheel. Mercedes-Benz also claims that this is the world's first sports car with a lounge-style interior, which is a bold new approach for the industry. The highlight of the Vision 111, however, is what powers it. While Mercedes has yet to officially release the powertrain specs, they've hinted that the axial flux motors will deliver motorsport-level horsepower and torque in a much smaller, lighter package. This results in a car that's not only lighter than its competitors, but also more agile, offering greater cornering ability without sacrificing stability. Thanks to the axial motor, the car's center of gravity is lower than it would be with a radial flux motor, further enhancing its handling performance. Thanks to the lightweight chassis, the powertrain won't face significant strain, and combined with the superior efficiency of the axial flux motors, this will result in a much longer range compared to competitors, something EV manufacturers have been striving for over the past 2 decades. You might think the Vision 111 is a one-off concept, but you'd be wrong. The Vision 111 is set to be a limited production, road-legal hypercar, meaning there's a chance you could see one in person. Of course, it's a slim chance, as only 111 units will be produced, and some of them won't even be available for purchase. Nevertheless, Mercedes continues to impress by revolutionizing the market and delivering what people want. There's a reason they're considered the best of the best. For now though, the Vision 111 will be the only model powered by an axial motor. Other models, like the Mercedes-Benz EQS, will continue to use more conventional engine types. As impressive as the axial flux motor is, it still faces a number of real-world challenges compared to more widely used alternatives. Mechanically, there are 2 significant complications during the design and production process. First, the single-stator dual rotor design includes 2 air gaps, whereas a radial flux motor only has 1. One gap exists between the first rotor disc and the stator, and the other between the second rotor disc and the stator. With these multiple gaps, maintaining uniformity becomes harder, leading to increased noise, vibration, and harshness compared to radial flux motors. The second issue, which is both a strength and a weakness of YASA's axial motor design, is the removal of the stator yoke. This yokeless design gives the motor 3 times the power density of a radial motor of the same size. However, it also makes the motor more difficult to manufacture. The stator yoke typically holds the stator teeth together to form a single unit. Without it, the stator sits in the middle and generates torque on both sides with the rotor discs, enhancing performance by virtually eliminating power and torque losses associated with the yoke. But from a production standpoint, it creates challenges, requiring significant re-engineering and making the motor costlier to produce, which limits its economic feasibility. That said, don't be discouraged. Mercedes has made it clear that they are committed to perfecting the axial flux motor design and plan to eventually integrate it into all their electric vehicles. This won't happen overnight, of course. Mercedes is still relatively new to the EV space, and it wouldn't make sense to overhaul their models just a year or 2 after they've launched. Instead, they plan to gradually incorporate the axial flux motor into their EV lineup, using the Vision 111 as a testing ground to identify and resolve any major issues with this ambitious new technology. In our view, the next time we see the axial flux motor will likely be in a production-ready EV supercar or hypercar, perhaps as the electric successor to the incredible Mercedes-AMG One. From there, it will likely trickle down into more affordable models until it's a standard feature in all Mercedes EVs. So while it's still in development, we're confident the axial flux motor is the future of electric vehicles, and we're excited to see its eventual adoption in upcoming EVs from Mercedes and beyond.